So, last Friday we started law of sines, and we worked on it straight up fine. Now today we're going to be doing the ambiguous case of the law of sines, which means things are going to get a little long. Okay, you're gonna have to actually think before you do any of the problem, because you got to figure out how many triangles that are actually there for you. Okay. So we'll get into that today. Tomorrow we'll do more of just different kinds of law of sines types ones. Thursday then we'll jump into law of cosines. Friday of this week we're going to do law of sine versus law of cosines, when you use one, when you use the other. Then next week, Tuesday, you'll take affirmative and we'll do some application problems from law of sines, law of cosines. Same on Wednesday, but you won't have the formative, you'll have one formative. And then we start reviewing, and then your test is on everything 5-3. So that was sum and difference of angles, to 5-4, which was double and half angles, to 5-5, which is law of sines, and wrapping up with 5-6, which is law of cosines. Okay, so you've got 4 different topics on this test on the 27th of February. Okay, here we go. So from Friday, you should have realized that the law of sines is the sine of any angle divided by its opposite side all the way through the triangle. Okay? So the sine of angle A divided by side A is the same as the sine of angle B divided by side B is the same as sine of angle C divided by side C. Okay? The sine value of an angle is proportional to its side length within a triangle. Okay? Now, this works on any triangle. That's why we have to learn this, because not everything in life is going to be a right triangle. So when we have non-right triangles, we need a way to solve them, to find things out of them. This law of sines, coupled with the law of cosines later on this week, allows us to do that. One caveat that I mentioned on Friday in class is that when you are using the law of the sines, because inverse sine is only found in quadrants 1 and 4, okay, on the right half of the unit circle, you are going to find by the way, we shorten law of sines to LOS, just so you know. You're going to use the law of sines to find the smallest angle first. Thinking back to your relationships with triangles, back when you were in geometry, where do I find the smallest angle? Or conversely, where would I find the biggest angle? So the biggest angle is opposite the longest side. So where's the smallest angle? Opposite the smallest side. Okay? Alright? So it is opposite the shortest side. Love it. All right. So there are 5 different ways that you can prove that triangles are congruent, and those 5 different ways that you're going to prove triangles are congruent are also 5 different ways that you can use, or the different ways that you can use law of cosines, law of sines. Okay? So the first way to prove that a triangle or two triangles are congruent, but we're only using one, okay, is side, side, side. Okay? So in proving, you prove that the three sides of one triangle were congruent to three sides of the other triangle. Okay? In solving here, or in using that, this is going to become a law of cosines problem. We'll get to that on Thursday when we have three sides given in one triangle. And we have to find three angles. Okay. Then there's side angle side, which for you was you had two congruent angles and one congruent side in two sets of triangles. For us, it's going to be two consecutive sides and the angle in between them. Okay? So what I mean by that is you've got a triangle and you're given a side, and the angle in between them. That also is going to be a law of the cosines, which we'll get to on Thursday. But it's a possible way to solve a triangle. The next way that you learned to solve two triangles are congruent is angle side angle. So you had two angles in one triangle and one side congruent to two angles in one side in another triangle. So this one, now for us, we would have an angle, a side, and an angle. This is a law of sines type of a solve. Why is this one? Excuse me, a law of sines. We got the triangle. Excuse me, the triangle sum theorem.
Yeah.
And what is the triangle sum theorem? What's A, what's B, and what's C? Because it's the angles. So angle A plus the three angles of the triangle add up to be 180 degrees. Yep, that's exactly right. Okay, right. So because that, then you have a complete fraction in the law of sines. So that's why that is a law of sines case. Okay. Next one is angle side. Okay. So now here you're going to have two. Oops, I should have put two consecutive here. Should have also been there. Yeah. White. Big. This one also should have been. For us, two consecutive angles. Yeah. So now you're given something that looks like that. And again, you can find the third angle using the triangle sum theorem. You already have your complete fraction in the law of sines, so you're good to go there. Okay? The last one that you learned when you were in geometry was hypotenuse leg. And that only works for right triangles. So we're not even going to worry about that one for us right now. But that was the fifth way of solving. Now, many many moons ago, I once taught the geometry. Actually, I taught geometry for a lot of years. Okay? And I loved it when we came to proving triangles because there's one case where you can't prove triangles are congruent. And that's when you use a naughty word. Okay? You can't use your angle side side to prove that triangles are congruent. But you can be given an angle, a side, and a side in that order and asked to solve the triangle. Okay? Now, here is where the ambiguous case comes in to play. Okay? So what I would like you to do as a warm-up, okay, is I would like you to find me just angle B in that angle side side scenario. So this would be the angle of the angle. This would be the side of the side and side. There's my angle side side case. Find me the angle right now. Side note, if you haven't figured out already that you're going to need a calculator today, and the rest of this, actually pretty much the rest of this semester, you're going to need some form of a calculator. So this would be the sine of 20.5 degrees over 12 equals the sine of angle B over 31. So doing some maths, we get 12 sines of B equals 31 sine of 20.5 degrees. Right? What did you get for? What'd you get? I heard 64.783 more than I heard 60 whatever. Which still I don't like. That's what I got. I got that. For angle B.
Maybe he did.
Well, are you saying that I'm wrong?
I think so.
Okay. So you figure out on your calculator right now what sine of 20.5 degrees is divided by 12. And I'm going to figure out what the sine of 115.217 degrees is divided by 31. No, I'm just, what did you get? What did you get for your 029184? 02918389294777. Same thing, isn't it? Who's right? What's ambiguous mean? Exactly. So we got a problem. Right? Because they both work. Right? So let's talk about what ambiguous means. Yeah? What does ambiguous mean? This is in English now, not in math. What is the word ambiguous mean?
Not clear.
Okay? Open to more than one interpretation, right? Okay? You guys probably didn't notice it, but the opening slide picture today is an ambiguous thing. Bat the animal or bat used in baseball? What? You can bat away with a bat, yeah? Okay? So ambiguous is open to more than one interpretation. Interpretation is a long word. Okay? So, this will only, the ambiguous case of the law of signs only happens if you're given an angle side side. Okay? That's the only time that it will happen. It will not happen if you're given side angle side or angle angle side. It will only happen given an angle, a side, and a side. Okay? So, the first scenario is your one angle that is given. If your angle is obtuse, so here's my angle, here's my side, there's my side. Okay? So if my given angle is obtuse, okay? So this side over here, we're going to call the opposite side because it is going to be across the triangle from the given angle. This other side, and it doesn't matter which position that it's in, either up here or down here, it doesn't matter, okay, based off of your triangle, but we're going to call that the adjacent side. We're going to steal the terminology from SOHCAHTOA. We can't use SOHCAHTOA because we're not in a right triangle. But we're going to steal the terminology from it so that we can at least have something that's the same. Okay? So if that is the case, then if there is a triangle formed, then the opposite side has to be longer than the adjacent side. And you only get one. If the opposite side is shorter than the adjacent side, then you get no triangle form. Because we would be violating that longest side is opposite the biggest angle. How many obtuse angles can you have in a triangle? You can only have one. Okay? You can only have one obtuse angle in a triangle. Because it can't be. Because of what I just said. The longest side in a triangle has to be across from the biggest angle. You just told me that we can only have one obtuse angle. So if angle that's given is obtuse, and the side that it's across from is shorter than another side in the triangle, it can't happen. Okay? So in an angle side case, you can have a triangle formed. You may not have any triangles formed. Okay? That's the whole ambiguous part of it. And these are checks that you've got to make every single problem going forward. Okay? Next now, let's switch to the given angle that we have is acute. Okay? So if the opposite side is bigger than the adjacent side, we get one triangle. If the adjacent side is bigger, then we're in the ambiguous case. Okay? So the first thing that you have to find is, so here would be my angle, here would be my side, and here would be my side. And this side is going to be the adjacent side. This side is going to be the opposite side. Okay? So the first thing that you need to find is you need to find the height of said triangle. Okay? The reason that you have to find the height of said triangle, so if we drop a height, heights are perpendicular to the other side. Now what have I formed? A right triangle. So the height of my triangle, I can use the sine of the angle that's given, is the height of the triangle divided by the adjacent side, because that's the hypotenuse of this mini triangle. So the height of my triangle is going to be the adjacent side times the sine of my given angle, always. Okay? So I figured that out first. Then I compare that to my opposite side. So first off, if my opposite side has an equal length to my hypotenuse, then I have a right triangle. One triangle is formed, and it is a right triangle. That's the very rare case.
that'd be a right triangle.
If when I find the height, let me change this up. Change this up. Change this up. Yeah, I'm gonna make this be. If, oops, sorry, I didn't realize that was too high. If the height is longer than my opposite side, then what's going to happen here is this is not going to be able to swing down and touch that bottom side at any point in time until it is as long as H. So if my opposite side is not longer than H, then I don't ever get a triangle. But if that opposite side is longer than the height, I get two triangles formed. I get a larger one out here, but then this side can swing back and it can touch over on the inside of that other one. So I get two triangles formed. Angle, here's my angle, here's my height, Okay. So that's a lot of information there in a little bit of time. Okay? So let's break it all down into when we're just dealing with the angle side case. Okay? So in an angle side case, if my opposite side is bigger than my adjacent side, so that would be here from this one triangle got formed, and down here in the obtuse case, opposite side was bigger than the adjacent, one triangle is formed. So in all of those cases, you get one triangle. If your opposite side is bigger, one triangle. If your opposite side is smaller, that's where all the checks got to happen. You could get 0 triangles, you could get 1 triangle, or you could get 2 triangles. Okay? So the first one is if it is obtuse. You'd get none. If it is acute, first thing you got to do is you got to check H. Remember, H is going to be the adjacent side times the sine of the given angle. Then, if H is equal, one right triangle. If H is bigger, no. And if H is smaller, you get 2. Memorize that. Make your life feel a lot easier. Memorize that. Yeah. Put it to work. Here we go. Do you feel as if drawing out a picture is very helpful to you? Yeah. 100%. Drawing out a picture is 100% helpful. Okay. Do you feel that showing your work is 100% helpful? Yeah, yeah, 100% in this case. No work shown on any of this stuff, no credit given. Okay? No work, no credit. All right, here we go. So we've got angle A. It is 42 degrees. We've got side B as 12, and we've got side A as 22. Which kind of a case am I in? Am I in an angle side-side case? Yes, I am in an angle side-side case. Okay? That means ambiguity is still on the table. Am I in an opposite longer or an opposite shorter than my adjacent side case? Opposite is longer. How many triangles get formed? Opposite longer case, no matter what. One triangle gets formed. Okay? So ambiguity is off the table. Now it's just a normal straight up, like we've been doing for a couple of years now, law of sines problem. Okay? So this would be angle B, this would be angle C, this would be side C. Those blue are the 3 that we need to find. Okay? So let's find them. Sine of 42 degrees divided by 22 is going to equal the sine of B divided by 12. Inverse sine. Again, it helps to make sure that your calculator is in degrees when you are doing this. Make sure your calculator is in degrees, otherwise you need to put in the degree symbol for it. What do we got for angle B here? Are we going to be using it later on? Yes, we are going to be using it later on, right? Don't round. Don't round. Okay? Right? Don't round. Because we're using it later. Right? If we're using it later, don't round.
What would you round? Always just leave it as.
don't round. Okay? Means don't round it. Okay? When it gets to the very end, then you can round it. And the directions will be on whatever it is that you are doing as to how many decimal places you want to round, or that we want it rounded to. So we're forcing you to read directions. Okay? So there's angle B. Now, how do I find angle C? Nope, we don't have the law of cosines.
Oh, angle. Yeah, you gotta add.
What is the angle sum theorem? You know, what equal 100 to the, all the angles? Okay, because we could multiply them, right? We could divide them, we could subtract them. So we have to be specific when we're saying these things, right? Okay? So all the angles, what, Sadie? Add up to be 180. So that means that 180 degrees minus 42 degrees minus whatever's on my calculator and then lastly, now we can use on your calculators, you should have an A and S key. That is going to be your favorite key coming up. Agree with what I got? Yes? Okay. Let's try that one. Angle C is 85 degrees. Side A is 25 degrees, or 25, and side C is 15. Angle side case, yay or nay? What is my relationship between my opposite and my adjacent? Okay. So what do we have to find first? Find the height first, right? So H is going to equal the adjacent side, which is 25, times the sine of the given angle, which is 85. What is 25 sines of 85? Okay. Then I have to compare the height to the opposite side. Which one is bigger? Height or the opposite side? The height is bigger. Zero triangles, because the opposite side doesn't come down and touch it, right? Yep. So no triangle formed. All right, on that one. One more to go. Well, it's gotta be. Right? Angle side case? Opposite compared to adjacent, which one's longer? Adjacent, which means, gotta check H first, right? Seven sines of 32. H versus opposite. Opposite's longer, which means two triangles get formed. Okay? You just knew. All right, here we go. So, first triangle. Actually, let me just bring this down. Okay. So we could say here then that the sine of 32 degrees divided by 5 is going to equal the sine of angle A divided by 7. right? What do we got for angle A? Okay. Then we can find angle B. Oops, sorry, angle C. Forgot to put in my sub ones here because there's going to be two of every one. So put it in subs. What do we got there? Yes? Yeah? Yeah? 32 all over 5. Why did I go back to this one and not use angle A inside A? No. Why did I go back to my original one that was given? Yeah, helps with all that consistency. Yep. So then we've got here C sine of 32 degrees equals 5 sines of 100.108 degrees. I gotta extend my page. C is 5. I get 9.2890 per side C sub 1. Yes? Okay. So that's the first triangle. Now, second triangle, you're going to go back and you're going to take whatever angle it is that you found first. So in this case, it was angle A. So angle A sub 2 is going to be the supplement to angle A sub 1. They are going to be supplementary angles. So you take 180 degrees and you subtract off that angle. So that gives me angle A sub 2 is 132.108 degrees. Then this calculation needs to be redone. And then this calculation down here, the only thing that's going to change for side C sub 2 is going to be the angle that you use. So you don't have to do all of that extra work for it. Okay? So now at the end then, you've got to label them as first angles and second angles. First angles, second angles. First sides, second sides.